everyone. Today we are going to start the new chapter, that is ray optics. Okay, so in this part we are going to discuss about the introduction of the ray optics. Then we are going to start the reflection and what are the images formed in front of the plane mirror, how the image is formed for point objects, for the extended objects, how the image will be formed. We are going to discuss in this part. Okay, let us start. So now, what is optics? See, what is optics? Optics means, simply we can say, it is the study of light. What is that? It is the study of light. Optics means it is the study of light. Okay, when we say light, what is that light? See, in the electromagnetic spectrum, this light is the one which helps us see various objects. What is that? Light is the part of the electromagnetic spectrum Okay, light is the part of the electromagnetic spectrum which helps us see various objects or different objects. Okay, that is the light we are talking about. Okay, let us see. Suppose there is this. What is the electromagnetic spectrum? Here, let us start from the radio waves. Okay, these are the waves which have the longest wavelength in the electromagnetic spectrum. Then after, we get the microwaves. After this, we have the infrared waves. Next, infrared rays. Then we have the ultraviolet rays. After this, we have this visible light. Okay, let me change the color once. Visible light. Okay, then after we are going to talk about X-rays. After this we get the gamma rays. Okay, so from here to here the lambda value increases, means wavelength increases. From gamma rays to radio waves, the wavelength increases for them. And when you look at that, in this part, the visible light, which is approximately 3800 angstroms to 7600 or 7800, or we may say approximately 4000 angstroms to 8000 angstroms. Okay, the visible light in between this range. Understood? Okay, so in this entire electromagnetic spectrum, this is the visible light and this is the part we are talking about. In this chapter, we are going to discuss about this visible light, which is part of this entire electromagnetic spectrum. Understood? Okay, now, so now in this, let us see what is optics. We may classify the optics into two categories. Basically, optics is a study of light. In this, we have classified into two parts. The study of light is classified into two parts. One, that is ray optics, which we are going to discuss in this chapter. Ray optics. And the other one is the wave optics. This we are going to discuss in the next chapter. Okay, so ray optics and wave optics. Basically, what is the difference between these two? See, ray optics. In ray optics, the dimensions of the objects is very much larger than the wavelength of light. Okay, what are the objects here we are talking about? We may say it as mirrors. Okay, we may say them as mirrors, lenses, and optical instruments like microscopes and all. Okay, so these are the dimension, means these are the objects which we are referring to when we say the dimensions of the objects is greater than the wavelength of the light. Okay, now coming to the wave optics. Here the dimensions of the objects are in comparable size with the wavelength of light. Okay, that much small size of the objects we are going to discuss in the wave optics part. Okay, mainly here our main primary focus is on this ray optics, and in this ray optics the dimensions of the objects like mirrors, lenses, and the optical instruments like microscopes, telescopes, the wavelength of the size means these objects are having very much larger size when compared to the wavelength of the light. Okay, right. So now let us see the basic points about the light now. Okay, so first we know that the light always travels in a straight line. Light always travels in straight line. So this is the basic point. And next, the path of the light is called ray. The path of the light is called ray. Okay, the path of the light is called ray. Next, the bundle of rays or the bunch of rays or the bundle of rays is called a beam of light. Okay, so these are the three basic points we have for the light. Okay, so light always travels in a straight line, path of the light is called a ray, and bundle of light rays is called beam. Okay, now we are going to see the first part of this chapter, which is reflection. So that's about the introduction so far we have discussed. Now we are going to enter the first part. Okay, in this light we are going to, if we have to separate this light into ray optics into two parts. First part is reflection, second part is refraction. Okay, now we are going to have the discussion about the reflection. And in this ray optics the number of concepts will be very high, means number of concepts will be more, but they will be very much easier. Okay, they will be easy concepts. This is the easy concept, easy chapter, and we can score the marks in this from this chapter. Okay, now let us start. So first, reflection. So let us start about this reflection. Now, so we know that laws of reflection, we know the laws of reflection. Let us consider there is a plane mirror. On this there is an incident ray, incident light ray, which is incidenting at the point O. At this point, let us take a normal, which is perpendicular to the surface. Okay, now this is the angle of incidence I. Okay, for this incident ray, there will be, when the light incident here, it gets reflected. Okay, it gets reflected along this path, and this is the reflected ray. And what is this? This is the angle of reflection. Okay, this gives the first law. What is that? The angle of incidence is equal to angle of reflection. So what is the angle of incidence? It is the angle between the incident ray and the normal. Angle of incidence is the angle between the incident ray and the normal. Angle of reflection, it is the angle between the reflected ray and the normal. Okay, right, this is the first law of reflection. Now coming to the second law of reflection. What is that? So the second law of reflection says the incident ray normal and reflected ray. When we say normal at point of incidence. Okay, normal, when we say normal, that is at the point of incidence. See, at this point there is a normal. At that particular point we are talking about. And reflected ray, all lie in the same plane. Okay, all lie in the same plane. So these are the two laws of reflection. Okay, now another point here we are going to discuss is when there is a spherical surface or any curved surface. Suppose there is a light incident here like this at this particular point. See, this circular surface has the normal. If we draw the normal here, it will be like this. This is the angle of incidence. This is the normal, this is the incident ray, and it gets reflected along this path. This is angle of reflection. This is the reflected ray. Okay, so now at this point, if you take the normal, it will be passing through the center. Okay, it will be passing through this center of this circular surface or spherical surface. Okay, now let us see normal incidence. let us see the normal incidence. What is this normal incidence? See, this is a plane mirror. On this, if a light ray is incidenting on that in the perpendicular to the surface, then at this particular point, if we draw the normal, it will be incidenting along this direction and it gets reflected back in the same path. Why is that? When the incident light is incident perpendicular to the surface, what is the angle of incidence? That is 0, because the angle between the normal and the incident ray here, it is 0. And then the angle of reflection is also 0, because the angle of incidence equal to angle of reflection. That is the first law of from the first law of reflection we can say that. So when the angle of incidence is 0, the angle of reflection is also will be 0. Understood?